So here is where we stopped in the last video talking about Lambert. So you should see something similar to this. So here we have Lambert um, using a spatial material, and today we're going to talk about the Lambert wrap. So the Lambert wrap just makes the light wrap around the sphere. So as you can see here, and now let's see how to implement that. So this is the sphere with a Lambert implemented. So this is the Godot implementation, and as we stopped in the last video, if we bring this up again, we can see. So today we're gonna see this script. So I kind of cleaned this up. So there's a bit of tied up. So I'm gonna walk you through so you better understand. You can also improve your code a little bit and align it with the Godot implementation and make it also easier for other developers to read. So here you can see the same stuff: shader type, the object color, the constant for pi. In the fragment color we are just applying the color, and here in the light is where we do all of our magic. So let's get started. So we're gonna need the normal, the light, the view, the roughness, attenuation, albedo, and light color. So here we're just instantiating the variables so we can better use it. This is the n.l. So let's just recap here. So this one is going to generate a value between -1 and 1. Keep that in mind. So this is the clamped n.l. Everything that is lower than 0, it's gonna change to 0. So if it's less than 0, it's gonna change to 0. So -1, now it's gonna be equal to 0, minus 0.9 equals to 0, and so on and so forth. I guess you got the idea. Here is the n.view. So the normal light dot the view. So this is beyond the scope of this video. We're gonna talk about the view space in another video. Let me know if you wanna know more about this in the comments. And this one is gonna do the same as this other one. So it's just gonna change everything that is below 0 to 0. So we're gonna have here every 0 to 1. So this is the new range here, and here as well, 0 to 1. So we're gonna have everything ranging from 0 to 1 here, and this one -1 to 1. Just so you know that we are clamping, not remapping. And here we're just renaming. So we're gonna have a Diffuse BRDF normal light here. So how we're gonna do it? So this is from our previous video. So this is what we had before. So just using the map. So this is the reflectance based on the dot product between the normal and the light. So depending if the light, the angle that the light is touching the surface, it's gonna give this as the radiance level. But Godot implements that multiplying by, dividing by m pi, because later down the track, as I mentioned in the other video, it's gonna multiply that by pi again. And today we're gonna talk about the Lambert wrap. I think it's worth mentioning before we go into that this is how we calculate the diffuse light. So the diffuse light is just the light color which comes from here. So you set that in the directional light. So here we're working with a white color, and then the diffuse color, which is the albedo, which is just what we set up in the object color here, and then we multiply that by the radiance level, and then the attenuation which is beyond the scope of this video as well. We can talk about this later, but this is provided by Godot in the attenuation variable as well. And then we have it, the diffuse light. We just assign that to the diffuse light variable, because if we don't do that, if we remember from the other video, it will just default to the Perley implementation. And then if you want to have multiple source of lights, you just add this, because as you may remember that this light function will run for every source light in the scene that touches this object. Okay, so having said all that, let's just move on to the Lambert wrap. The Lambert wrap is just a pretty straightforward implementation. So basically, you're just getting the n.l, which is similar to what we did to the Lambert implementation, and then you add the roughness. So you can say that the Lambert wrap is just Lambert accounting for the roughness of the surface. So what does that mean? That means that if we, let's play around a bit so you can better understand what we are doing here. So right now the roughness is 1, so it allows the light to wrap around the sphere. If we remove the roughness, we're gonna end up with just a Lambert implementation. So let's see why here. So here you can see that n.l, which is the same as the Lambert. So we're gonna end up with any number here, so it doesn't matter. And then we're gonna say that roughness is 0, so this one is cancel. Let me get this here. So if the roughness is 0, we can remove it. Then plus 0, we can remove it. Plus 0, we can remove it. Times 1 is the same as nothing, right? Is the same as itself. And divided by 1 is the same as itself. We're gonna end up with just n.l, which is the same implementation as this one here. So this is where things get tricky here, because a 0 roughness is gonna give us Lambert, but in the Godot implementation, we end up with Lambert without dividing by pi. So if we just leave it here, so this is the Lambert implementation with roughness 0. If we compare with a sphere implemented by Godot using Lambert, you can see that they are pretty different. So if you want the same, we should compensate by that, as we saw in the other video. So with a roughness 0, we should have it divided by pi, as the Godot implementation here. And then we should have a similar, see that now there's no difference. So I'm gonna leave this one open to the Godot developers, or if someone knows why they implemented the Lambert wrap without dividing by pi, because from my perspective sounds like it's not ideal. Either this one is wrong or this one. I assume that this one is not correct, but I'm gonna leave it here. In terms of how this is implemented, let's just remember what we can do to match what we want to achieve, and not how they implement it, right? Okay, so now if we go back to roughness 1 and leave the n.pi 1, we need to turn it off. So this, I believe this is the effect that you are trying to achieve with the Lambert wrap. Why is that? Because if we don't compensate with the pi being multiplied later down the track by Godot, we're gonna have this. And if you remember the other video, we can always check what the light is doing. And if we turn on our debug colors, we can see here that we're gonna end up with a value way higher than 1 here in all of this. If we plug the numbers in here, you should be able to see what I mean. So let's pretend that at here, at this exact spot where the light is hitting the surface perpendicular, we're gonna have 1, right? And then we're saying that we have a roughness of 1, and then 1, and then 1 again. If we calculate here, we should end up with 2, and then 2 again, and then 2. And now, if we multiply here, we're gonna have 4 divided by 4, and then 2 divided by 4, which is gonna end up with, we're gonna end up with 0.5. And then if we multiply 0.5 times 3 and plug that in, we're gonna end up with 1.57 times pi. We're gonna end up with 1.57 whatever. Let's confirm that, right? So let's say that if it's lower than 1.6 and bigger than 1.5, and here if it's bigger than 1.5. Do we have anything bigger than 1.6? No, we don't. See? So because Godot is multiplying later by pi, we're gonna end up with this value here, 1.57. And as you can see, we don't have any magenta here because 1.57 is the final value of the light around this point. Let me just go back here. And 1. So all of these is 1. You see the blue light? So the blue light is where it reaches 1 and then it starts increasing all the way up to 1.57. Okay, I think that's enough. Where the pi makes sense in the Godot implementation here, and then if you want to compensate, you're gonna need to divide by pi, so that at the end you're gonna end up with something here 0.5. Then you're gonna have a smooth transition down here, and then if we move it back to 0, you're just gonna end up with the Lambert implementation. Then you have again 1 here. So anyway, this is how the Lambert wrap works in Godot. I hope it makes sense for you. We're gonna improve in this code, and also we're gonna talk about the Oren. The next one is gonna be Oren Neuer, so we can have a better idea of how Godot implements lighting, and hopefully you'll be able to decide by yourself how and what you want to implement, and everything that is having a play in the implementation, all the variables, and how Godot do its calculation. Hope this is helpful, and I'm gonna see you next time.